Hello, my amazing students. This is Mrs. A, and these are the problems that I promised you from 4.3. Now remember, in 4.3, we are actually writing the equations of the line. So it's a little bit harder. This first set of questions says, write in standard form, and it gives me an equation. And the equation is not in standard form. Now remember, standard form has two rules, really three rules. It's ax plus by equals c. That's our standard form. So ax plus by equals c is our standard form. And we're not allowed to have a negative on the first term, which is the x term. And we're not allowed to have fractions. So this keeps the answers standard, which is the whole purpose behind a standard form. So you see we've got a negative 5x, so the first thing we could do is just multiply everything through by a negative 1, which is what I will do, and we will get a 5x plus 11 equals negative 2y. Okay, and you can see that now I want my y over here and I want my constant on the right. So I usually deal with my variables first. So I'm going to add a 2y to both sides. Okay, and then that's going to leave me plus 2y plus 11 equals 0. So I just added a 2y to both sides, and now my last step will be to just get this 11 on the other side, which means I'm going to subtract an 11 here and subtract an 11 here, and since I'm out of room on this problem, I'm going to erase that and write the correct answer, negative 11. So we have 5x plus 2y is negative 11 is the correct form. So now we're going to do this one on the bottom, which is already in slope-intercept form, and we want to put it in our standard form. So what we're going to do is first get rid of those fractions. Fractions are not going to be in standard form. So why don't we multiply everything through by the least common denominator. So we're going to multiply everything through by 12, and we're going to end up with 12y is equal to 12 times 1/3 is 4x, and then minus 12 times 3/4 is 9. Okay, so then we need to get it in standard form, so we need our x over here, and so we're going to end up with a negative 4x and a negative 4x over here, so we get a negative 4x plus 12y equals, this goes out, equals negative 9. And now we've got a problem again because we're negative on our front term, our x term, so we're going to just go through and change every sign, which is multiplying everything through by a negative 1. So that's going to make this negative become a positive, this positive become a negative, and this last one become a positive. So 4x minus 12y equals 9 is the standard form of this equation right here. So now I'll be back with number 2 problem. All right, the second problem we're going to do is to write an equation when we are given a slope and a y-intercept. Okay, so since we're given a slope and a y-intercept, we already have a form of the line, the slope-intercept form of the line, which is already set up to take a slope and a y-intercept. So it tells us to leave it in slope-intercept form. So this is like a no-work problem. We know that y is mx plus b is our formula, and we have a slope of negative 3, and there we go. So we put our slope in, and then our b is our y-intercept, so we're going to plug in a 2. So y is negative 3x plus 2 is in slope-intercept form, and we're done. Okay, so now we're going to do the number 3 problem. Write the equation. M is 6, y is intercept, the y-intercept is 0, 3, and we're to write this in standard form. So slope-intercept, we're going to start it in slope-intercept form. Y is mx, which is going to be 6x plus b, and the b is 0, 3. So that is in slope-intercept form. And now we got to turn it around to standard form, which of course is ax plus by equals c. So now we need to turn this around. We need our x on the left with the y. So if we subtract a 6x here and subtract a 6x over here, we wind up with negative 6x plus y is, this goes out, 3. We're almost there. What's the problem here? Remember, we can't have a negative on our x term. So we're going to multiply everything by -1, which means we change this negative to a positive, this positive to a negative, and this positive to a negative. And now that will be the answer to our problem. Okay, here's our 4th problem, and we are given a slope and a point that is not the y-intercept. So we're going to use the point slope form of the line, and then we need to turn it into standard form. So remember, your point slope form is y minus y1 is m x minus x1. And remember, we derived that form of the line from the slope formula. So now we're going to substitute in our particular point. X is -1, so we'll put the particular x here, -1. And then y is -4, so we'll put our y1 here as -4. And then we're going to simplify it some and put our slope in. Slope is -1. But this is not the form that we want to leave it in. We want to leave it in standard form. So y plus 4, because minus a minus is a plus, is equal to -1 times x plus 1. So now this -1 is going to distribute through, and we're going to have y plus 4 equals -x minus 1. And now I'm close, right? I need to get this x over to the right. So I'm going to add an x and add an x over here. So I wind up with x plus y plus 4 equals -1. And then I need to send my 4 over here, subtract 4, subtract 4. So we get x plus y equals -5. Okay, now we're going to come back and show you another way to do that using the slope-intercept formula of the line. So here we are, and I have put the equation we just found out, x plus y is -5, up at the top here. And I'm starting the problem over with the slope and the point, but I am going to use the slope-intercept form of the line just to give you an alternative method. Y is mx plus b can be used to solve an equation, to get an equation when we have a slope at a point. Because the slope goes right here where the m is, so the slope was -1. And remember that any point that is on the line should make the equation true. So since this point is on the line, I'm going to take the -1 and I'm going to say, okay, the x is -1 when the y is -4. So we're going to put the -4 over here where the y was. So now we're going to crank it around and see what happens. So -1 times -1 is 1. And so we get a -4 is 1 plus b. And if we subtract 1 and subtract 1 from both sides, then we get -5 is b. So my y-intercept is -5 to make this true. So now I can go put this back into the slope-intercept form. Y is mx plus b. And instead of the b, I'm going to plug in the -5. And instead of the slope, I'm going to plug in the -1. And that is the slope-intercept form of my desired line. Then I'm going to turn this around to be the standard form, because that's what I'm supposed to leave it in. If I add a 1x or just an x to both sides, then I get x plus y is -5, which is the form I came up with before. So now you have two ways that you can come up with an equation given a point and a slope. So our next problem is going to be involving a slope and a point, and we're going to leave it in slope-intercept form. So we could use either method. Again, I could use my point slope method, or I could use my slope-intercept method. Since I have to leave it in slope-intercept form, I'm going to do it that way. So y is mx plus b. My slope is already -3. So the only thing we need to find is my b, my y-intercept. So I'm going to plug in this known point, and I'm going to change my x to be a 2 and my y to be a 5. And now I've got 5 is -6 plus b. Add a 6 to both sides of the equation, and I get 11 is b. So now all I have to do is put it into my slope-intercept form again. Y is mx plus b, but b is 11. My slope is, from my problem, -3. And that is the slope-intercept form of that line. And you can plug in 2, 5 here and here, and you can see that it does make the equation true, and we do know that the slope is -3, so you can easily check them. So here we have 2 points. No slope is given. When we have 2 points, we have to use the 2 points to find the slope, and then we're going to use the slope and either one of the points to find the equation of the line. We want this one to be in slope-intercept form. So it doesn't matter which way I put my points. I could use this as point 1 and this as point 2, or I could switch them. I'm just going to use 4 take away a -2, 4 take away a -2 over -3 take away 5. Okay, so as long as I'm consistent, I can use the points in any order. So 4 minus a -2 is 6, because that becomes an addition, and -3 take away 5 more is going to be a -8. So now I've got a -3/4 slope when I reduce -6/8. So now I'm going to say y is m, which is -3/4, x plus b. Okay, so now I need to find out what the b is. So if I use 5, -2, either one of the points will do. I'm going to plug in a 5 here. I'm going to plug in the -2 here, where the y is. So I plug in the x for the x and the y for the y. So now I'm got -2 is -15/4 plus b. But I just want b. So I'm going to add 15/4 and add 15/4 to the other side, so that I get b equals, All right, so when I add the 15/4, this is going to cancel. Now I have to do this math. So this is easier if I remember that -2 is -8/4. So I'm going to take the -2 and I'm going to make it -8/4 because I'm running out of room on my board. So now I have -8/4 plus 15/4 is 7/4. Okay, so I wind up with the equation of the line is going to be y, let me see if I can write this real small. Y is m, and our m was -3/4, x plus 7/4. Okay, so up there in the little corner is the slope, the equation of the line as we found it. So now I'm going to use the same equation, but I'm going to do it with the other point just to show you that we're going to wind up with the same thing. Move this over. All right, so we'll do it on this board here. So we had the slope was -3/4, and now I'm going to use the other point. I used 5, -2, so we're going to use -3, 4. The other point that was given to us. So y is m, so -3/4 x plus b. If I plug in -3 instead of the x, and I plug in 4 for the y, then I'm going to end up here with a -9/4 plus b is 4. Can't read my writing. So then I'm going to add the 9/4 to both sides to get my b by itself. So b is equal to, now I've got to take my 4 and turn it into something over 4. We know that 4 is 16 over 4. 4 is 16 over 4 plus 9 over 4 is going to be, whoops, I see what I made my mistake. The -3/4 and the -3/4, that's a positive 9/4. So that means I have to subtract a 9/4, and that means I have to subtract a 9/4. I should get the same answer both ways. I made a sign error. So now I get a 16 minus a 9, which is a 7/4. So we get the same b we had before, and we get y is -3/4 x plus 7/4, which is exactly what we had the other time we worked the same problem using the opposite point. Okay, so this is just showing you different ways to do different problems so that you get to be literate with creating an equation that fits a given situation. You don't want to be tied to one method. All right, so here we go. We're going to do this one, which says we have a slope and a point, and we're going to put it in slope-intercept form. So we've done several of these. M is -3. The point is 2, 5. Okay, we're going to do y is mx plus b. Now, I use that a lot. That's my favorite one. Remember, you could use y minus y1 is mx minus x1. Both methods work. Both methods are correct. Okay, I just tend to prefer this one. So I'm going to erase that one. So here we've got our slope is -3. Okay, so now we're going to plug in our point. Our x value is 2, and our y value is 5. So now we've got 5 is -6 plus b, or b is, if I add 6 to both sides, I get b is 11. That looks awfully familiar. I think I already worked that problem. I did work that problem, so we'll skip that one. Okay, and I think we are done with that set. I'll be back with parallel and perpendicular lines. All right, so here we have 2 points, and we're going to put them in standard form. So since we have 2 points, we have to find first a slope. So 7 take away 3 is 4. 4 take away 2 is 2. 4 divided by 2 is 2. Remember, our y's are on the top and our x's are always on the bottom. So we have y is mx plus b, and 2 goes where the m is. Our b, we don't know, so we're going to plug in either one of these points. We'll just use the 4 and the 7. So x is 4, y is 7. So now we're going to, this is 8, so we're going to take away 8 from both sides, and we get b is -1. So now we plug in y is m, which was 2, x minus 1, so that is the slope-intercept form of the line, but we need it in the standard form of the line. So we need to move this 2x to the front, so minus 2x minus 2x. So we get a minus 2x plus y is -1. What's the problem there with that one? Our first term can't be negative on standard form, so we're going to change each term to the opposite sign so that I get 2x minus y is 1. Okay, so we're going to talk about our x and y lines again. Remember, x lines cut the x-axis. So x lines are vertical. Y lines cut the y-axis, so y lines are horizontal. So here it says find the equation of the horizontal line containing -8, 6. If we think of a horizontal line, it is a y line because y cuts the y-axis and is parallel to the x-axis. Okay, so since this is going to be a y line, we're going to use the y coordinate of the point, and we're going to say y is 6. Done deal. That's all we have to do. For the next one, it says a line with undefined slope. We know an undefined slope is a vertical line. X lines cut the x-axis, so this is an x line. Therefore, we will use the x coordinate of the point, which is 6. So x is 6 is the equation of that line. All right, some of you have asked me to put this one out here one more time. So this is the development that I did for you in class. This is taking the standard form of the line, ax plus by is equal to c, and turning it around into slope-intercept form. I'm doing it with the generic A, B, and C so that it works with every single line. So remember that my slope-intercept form has y equals, so I want to get y by itself. So I'm going to subtract the ax, and over here I'm going to subtract the ax from both sides. So now this is going to go out. I'm going to get by equals, and I'm going to put the x value first, so -ax plus c. So now slope-intercept form has just a y. So I'm going to divide by the b, and divide by the b, and divide by the b. And lo and behold, I have it in slope-intercept form. Because here I just have a y equals. And then I have -a over b x plus c over b. All right, now remember our slope-intercept form of the line is y is mx plus b. So when you compare the two, since I have them both solved for y, my m, or my slope, must be -a over b, and my little b, which is my y-intercept, must be my c over b in my original equation. So remember, we're going back to ax plus by is c. Anytime we do that, we know the slope of this line is -a over b. Whatever is here divided by whatever is here with the opposite sign. Okay, and then the little b, which is the y-intercept, is always going to be this value over the b. So c over b is always my y-intercept. So now we're going to use that cool technique to make this problem a little bit easier to solve, because here we have a system and we're trying to figure out, is this system of linear equations, are they parallel, perpendicular, or neither? Okay, so parallel lines have the same slope, perpendicular lines have the negative reciprocal slopes of each other, and neither would not follow either one of those rules. Okay, so when I'm talking about parallel or perpendicular, what I care about is the slope. So what is the slope of this line up here? Okay, so we're looking at negative a over b. Negative a is going to be positive 2. 2 over 6. So 2 over 6 is the slope of the first line, which will reduce to 1/3. Okay, now I look at the second line, and I have the opposite of this one, negative 4 over negative 12, and negative 4 over negative 12 is equal to 1/3. Since the two lines have the same slope, they are parallel. Okay, the two lines are parallel. Okay, so now we have two lines. One of them is in standard form and one of them is in slope-intercept form. So we already know the slope of the second one. Since we're solved for y, the slope is always joined with the x variable, but remember, the x is not part of the slope. It's the number in front of the slope. So now all we have to do is find out the slope. I'm going to use my little negative a over b trick because it is in standard form. So negative 8 over 6 is negative 4/3. So my first one is 3/4. My second one is negative 4/3. They are flipped over and opposite signs. So these two are perpendicular. That's our little perpendicular sign. Perpendicular. Okay? All right, so now we are looking at parallel, perpendicular, or neither. And when we're looking at these, we've got this one is in standard form and this one is in standard form. So the slope here is going to be the opposite of this one, negative 2 over negative 1, which is going to be a slope of 2. Okay, the slope of this one is going to be the opposite of this one, negative 6 over this one, which is 3. That winds up being negative 2. They are opposite signs, but they are not reciprocals. So this one is neither parallel nor perpendicular. All right, we're almost done. So here we have some little special situations. Line contains 5, negative 1 and is parallel to y is 2x minus 1/2. The only thing that we need with this line right here is its slope, because our desired line is going to be parallel to this one. So we have it in slope-intercept form. So our slope is 2. Therefore, our desired slope for our line is 2. And it's going through 5, negative 1. And we're going to put it in slope-intercept form. So I'm going to do this one a little differently because I haven't done the point-slope form for a little bit. I'm going to use the point slope and then put it into slope-intercept form. So y minus y1, here's my y1 is negative 1, is equal to m, and our m is 2, x minus x1, which is 5. So I'm going to distribute here. 2x minus 10 is y plus 1. All right, so I need it in slope-intercept form. So I already have my y by itself, so I'm going to subtract a 1 and subtract a 1, and I get y is 2x minus 11. So that wasn't so hard to do using the point slope form of the line. Last problem on this little video that is covering 4.3, making equations of lines. So we're going to find the standard form for the equation that contains this point, -4, -2, and is perpendicular to 3x plus y equals 7. So again, all we want with this line right here is to find its slope so that we can get a perpendicular slope, which is a negative reciprocal to go for our line. So we look at this line right here, we say, okay, negative a over b is -3 over, since there's nothing there, it is a 1, so -3 over 1 is -3. That is the slope of the reference line here. So the perpendicular slope will be flipping that over, and remember there's a 1 underneath it, so when I flip it over, so we'll say perpendicular is going to be 1 over 3 with a positive sign. So I flip it over, and that is my desired slope. So we're going to say m is 1/3, and -4, -2 is our point. So we'll do it with the y is mx plus b again. And so our m is 1/3. Our x is -4. We can plug that in because this is a point that makes the line true. And a -2 over here. So we end up with a -4/3 on this side, but we want to get this into standard form. So we're going to wind up having to get this b over here. So we'll say this is going to be -4/3. Here, when I move it to the other side, it becomes a +4/3, and a -2 is b. So -2 is -6/3. So I have a -6/3 plus a 4/3 is a -2/3, which is my b. So my b right here is a -2/3. Let me get another board here. So now I have my b is -2/3, and I have my y is 1/3 x minus 2/3. In my slope-intercept form, I want to turn that into standard form, so I'm just going to multiply everything by 3. Because remember, I don't have any fractions in standard form. So if I multiply everything by 3, I get 3y is x minus 2. Standard form has this x on the other side, so I have to subtract the x. So now I have -x plus 3y is -2. But now I have to multiply everything by a negative because we can't have a negative on the front, which changes this sign to positive, this sign to negative, and this sign to positive. So x minus 3y equals 2 is the equation of the desired line in standard form, and we have very thoroughly covered 4.3. May God bless your day.